Hello everyone, welcome back to Turito's live class. So we have already started a brand new chapter called as Matter in Our Surroundings. This session is in continuation with the concepts which we have learned in the last session. Okay, so are you all able to recall the concepts which we have studied till the last class? Let's quickly recall whatever we have learned so far. So we have studied about the physical classification of matter. We know that matter is divided into two categories. Depends on its physical properties, we know that we have physical classification. And second category is based on the chemical properties, and that's how we have studied about the chemical classification of matter. Okay, so physical classification was all about the different states of matter such as liquids, solids, gases, plasma and Bose-Einstein condensate, right? That was BEC. So basically we have studied how matter is having different states and what are those different properties which are responsible for the structural arrangement of these different types of states. Are you all able to recall? Like we studied about the interparticulate spaces and also the force of attraction which these particles are experiences and the trends among solid, liquids and gases. Hopefully yes. Okay. So in today's class we are going to move ahead and going to learn very interesting concepts such as what? Interconversion of matter. And second is effect of temperature and pressure. Now what these terms are? If I want to split the word and get the meaning out of that, what we can do is just split the word inter and the rest part is conversion. So when we talk about interconversion, basically inter is nothing but something which is happening between two molecules or particles or any chemical species. Conversion, so something is getting converted into the other. So that's how the word is interconversion of matter. Now what is that? Let's try to understand. So here is the proper definition of, it is nothing but a phenomenon of conversion of one state of substance into another state without changing its chemical composition. Have you seen, I am emphasizing on the word chemical composition. Basically you are just shifting one state of matter into other, but we are making sure that the chemical composition will not get disturbed. Now what does it mean? Let's take example and try to understand it one by one. Suppose I am having an ice cube like this. Okay, this is what is your ice. We know that this is what we have observed whenever we are taking ice cubes from the freezer. After a few minutes or after some time, this is what is observed, that this ice is getting melted and it is giving you what? Liquid. And that's what we called as water, right? And what will happen if we are going to supply some amount of heat to the liquid? It is going to get transformed into, on application of heat, okay, let's suppose we are applying some heat to this, okay. So on application of heat, now these liquid molecules are going to get transformed into the next state, that is what? Gaseous state. So let's label them out. It was a solid, ice was a solid, then we had liquid, that is nothing but water, and when we boiled it off we got gaseous substance, that is nothing but what? Water vapors. Okay, so from solid to liquid to what? Gas. something had happened between or among these states. Basically, that is nothing but what? Interconversion. You have converted one state of matter into other. Now, my question is that what is the chemical formula for water? How do we write water chemically? If I am not wrong, something like this. H2O, right? Dihydrogen oxide is the chemical name of water. When I see the arrangement of the particles here and the arrangement of particles here also and arrangement of particles in here also. So my question is that chemically is H2O get vary? The chemical composition got disturbed? No. The substance remained the same. So H2O didn't get transformed into H2O2 or H2O3. No. It is remaining throughout these all states constant. And that's what is the main part of interconversion. So again repeat, phenomenon of conversion of one state of substance into another state without changing its chemical composition is known as interconversion of matter. Got it? So now moving ahead, interconvergence of states of matter also considered as phase transition. What? Phase transition. So phase is nothing but it's equivalent to state. Okay, from one phase to other, from one state to another state. The transition is happening, and that's how we can say phase transition of matter, also known as interconversion of states of matter. Are we all clear with this, the definition? Great. Now let's move ahead and try to understand this deeply. So basically, solid can get converted into what? Liquid. Liquid can get converted into what? Gaseous particles. Okay. So this conversion can get reverse also. Okay. So like gaseous particles can get converted into liquid also. Okay. Solids can get converted into directly into gaseous particles also. Do you know there is one phenomenon whenever we observe this shift from solid to gas? What is that? Very correct. That is nothing but sublimation. Right. Now, even liquid can get converted into solid. So internally all the shifts, all the conversions can happen, and that's how we say it's interconversion of states of matter. I am hoping that you all are following till here. Okay, great. So my question is that I have a small question here. If a solid is getting converted directly into gas, we have shown one arrow here. Did you guys notice that? Like that means gas can be get converted into solid particles. Can anyone tell me like what do we call it as? If solid into gas is known as sublimation, then gas into solid is known as? Here is the different phenomena. That is nothing but desublimation. What it is that? Desublimation, something reverse to something opposed to sublimation. Desublimation is happening. Okay, so this was a pictorial diagram to understand the interconversion of solid to liquid to gas, solid to gas or gas to liquid, etc. Now moving ahead. So my question is to you that like how this transition or shift must be happening. Is there any parameter which one is responsible to make that shift happen? Yes, there are some variables such as temperature, pressure and volume. We are using word variables. That means we can, increase or decrease them. Like if like keeping temperature increasing, we can see the change in the volume. Now if I want to increase the pressure, I can see the change in the volume. If by keeping volume constant, and if I am changing the pressure, if I am changing the temperature, then what is the result, what is the observation when we are changing these three things? Okay, so actually result is nothing but transitions are going to happen. If you are going to increase the temperature, if you are going to decrease it, if you are going to supply more amount of pressure or going to increase it, basically internally the shift is going to happen from one state to another. Okay, so these are some variables who are responsible for this shift or transition. Now in today's topic, as I told you, that we are going to learn about the effect of variables such as effect of temperature. That is our first variable which we are going to study about in detail. So effect of temperature, that means if we are going to increase the temperature, then what is the result among the states of matter? If we are going to decrease the temperature, then how the shift is going to happen? That is all about the effect of temperature. We are going to see it shortly, but have you all followed till here? Like, what is that effect of temperature? Great. So let's try to understand it. Yeah. So by increasing the temperature, ice can be converted into liquid. Now further heating converts liquid into water or water vapor, sorry. Now change in temperature transforms one state of a substance into another state. So again, just now I told you, let's suppose we are provided with solid particles. Okay, now we are increasing the heat of the system. Okay, we are going to supply some amount of heat to the solids. These are solids. Let me write it here. So according to statements, solids are going to get shift into what? Liquids. But how? Or how the structural arrangement will look like? What will happen with the particles? They are going to move away from each other, and that's what the property of liquid particles which we have studied. On application of heat, solids are going to change into liquids. Okay, these are nothing but liquids. Now again, if I am going to supply heat to this, as we have already seen, liquids are going to transform themselves into what? Gases. Correct? So that is the effect of increasing temperature. There is different way to show if you are going to supply some amount of heat to the system. That's a triangle which denotes that we have supplied some amount of heat to the system. Liquids on heat going to get you a gaseous state of matter. That is all about an effect of temperature. But how this shift is happening just because of increasing temperature? Can anyone tell me the mechanism? What exactly must be happening among these particles? Let's try to understand that. These are the solid particles. Okay, is it visible for you all? Now, when you are supplying heat to the system, we know that these are having strongest force of attraction among them. And when you are going to supply some heat to the system, what is going to happen? All particles are going to absorb the energy from the source, and now their kinetic energy is going to get increased. they will be, getting energized, they are going to get charged, and that's how they are going to pass the energy among themselves. What is the result? Result is that there will be, like less force of attraction, because of they are getting energized, and there will be breakage of bonds, and that's how these particles are moving away from each other. Okay, and that's how they are forming liquids. Now to the liquids, if you are again going to supply some heat, again they are going to get absorb the extra amount of heat. So again there will be like more energy in their system, they're again going to get energized, and because of extra energy they all are very activated, and that's why they will start to move from here to there, resulting into the distance, like there will be increase in the distances or spaces will get generated among themselves. Less force of attraction will be there. This is what is gaseous state. And why did this happen? Because of increasing of temperature. Followed? Great. Now question arises, ma'am, if temperature is getting increased, we are following this trend. Will it be possible if we are going to reduce the temperature or decrease the temperature, it will, shift will get in reverse direction? Absolutely. So here what we can do, we are going to cool down. So gaseous particles which are very activated, which are very energized, now cool them down. Stop the supply of heat. Give them time, let them settle, let them cool down for some time. After cooling, what is going to happen? Actually these particles are going to come very closer to each other. Okay, after cooling them down. And that's how the distances or the spaces among them is going to decrease, which is going to give you liquids. Now liquids again on cooling, if you are going to cool them down, if you are going to decrease the temperature, again the spaces are going to get decreased, and eventually you are going to get solids. Okay, this is how we get the solids on decreasing the temperature of the system. Follow till here. Quickly make a note of this if you want to, or try to draw this diagram, so that it will become very easy for you to understand after the class. Done? All right. Moving ahead, yes, again, whatever we have learned, we are just, making a pictorial image of the, trends or shifts. Solids on heat become liquids, liquids on heat become gaseous substances. Okay, now further on cooling, we are getting back to liquids. Liquids on again cooling, solids. Quickly draw this diagram. If you are very clear with this, you don't even need to read these sentences, because your concepts are really very clear with the help of this diagram itself. Okay. Let's move ahead. So, temperature. We have talked about temperature so far. Can anyone define what is a temperature? We all must have studied about it in our lower grades, right? What is a temperature? Temperature is nothing but degree of coldness or hotness of matter. How cold the matter is, how hot the matter is. So temperature helps us to measure the coldness or the hotness of that particular matter, right? So we are having SI unit of temperature is what? Kelvin, capital K. And different, or we can use the other one, that is degree Celsius. There is the relation between these two, units. We can interchange them, like to get if we are provided a temperature with in degree Celsius, we can shift it into Kelvin by adding the degree Celsius temperature with 273.15. Okay, so that's how interchange can happen. Got it? Now next we are having a second variable such as effect of pressure. So try to understand like what will be happening when we are going to increase the pressure on the system or on the states of matter. How the transition is must be getting formed. So let's try to understand. By increasing pressure, particles come closer and hence their state changes. By increasing temperature, particles they are having this tendency to come closer, and that's how they change their states. So here we are having like gas, okay, gaseous particles can be converted into liquid. Okay, the shift is like this from gaseous particles to liquids. And again liquid can get transferred into solid by application of pressure. How? Let's try to understand. Consider we are provided with gas molecules. Okay, this is nothing but gas. And there is a thing called as a piston. This is what is a piston. Okay, with the help of this piston, what you all are going to do, we are going to try to apply some pressure on the system with the help of piston. And if you are applying some pressure, what is the result? Okay, look here, the height of the system or the container. Now on application of pressure, the height of the system is getting reduced. Volume of the system is getting reduced. Why? Because these molecules are getting close to each other. When you're applying some pressure, molecules are having tendency to come closer, and after coming closer, they are shifting themselves from gaseous state into liquid state. Which state is this? Liquid. Now, if we are going to apply more pressure on the system, what must be happening? Again, the molecules are going to come closer to each other, and that's how there will be reduction in the area or the volume which they are provided with. This is nothing but which state? Solid. So initially we were provided with gaseous particles. On application of pressure, they are going to get converted into liquids because these particles are coming closer to each other. Okay, and that's how the volume or the area is getting reduced. They are now quite nearer to each other than they were in the gaseous particles or gaseous state. Okay, again if you are going to continue with the application of pressure, these particles are going to get come closer. They are going to have that compact arrangement, and this is what is solid is. Okay, so that's how by increasing pressure, particles they come closer, and then there is a shift of internally there is a change is happening, like from gaseous to liquid to solid. Followed? Is there any confusion? Is there any doubt from your end? Okay. I hope you all are making note out of this, right? Okay. So like temperature, for pressure also we are having SI unit, that is Pascal, PA, and the other unit is atmospheric pressure, or like atmosphere, ATM. Okay, so ATM or PA, these are two units. Okay, where is 1 ATM is nothing but it's equal to 1.01 into 10 raised to 5 Pascal. That is what is the interrelation between these two units. Okay. So that's how we are towards the end of the session, and we have covered the topics which we were aimed for. Okay. So first we have studied about the interconversion of matter. That interconversion was from solid to liquid to gas. And then we have studied about the effect of temperature and pressure. Okay. So let's move further. It's time to solve some questions which is based on the concepts which we have covered so far. A few substances are arranged in the increasing order of forces of attraction, okay, between their particles. So forces of attraction is getting increase. Which one of the following represents correct arrangement? So your options are option A, water, air, wind, B, air, sugar, oil, C, oxygen, water, sugar, D, salt, juice, air. So you are provided with these four options. Just try to apply the concept which we have learned and tell me which one should be the correct answer. Did you get the question? Shall I repeat it for you all? So these are some examples of matter, and we need to arrange these substances according to what should be the pattern, increasing order of that force of attraction. Quickly. Those who know the answer, please keep typing in the chat box so that I will get an idea. Okay, so let's deal with this and try to understand it. Okay, force, increasing order of forces of attraction. So among solid, liquid and gas. Suppose these are these three states of matter which we have studied. Let's try to understand their structural arrangement. As we all have studied, like solid particles are very compact, they are very rigid, they are very closely packed, right? What about liquids? They have some spaces, right? They are a bit far away from each other when we are comparing it with solids. Moving ahead, we are having gaseous substances or gaseous state. Here, the distance among these particles is quite largest among these three states of matter. Now, when there is less space, if there is a less interstitial space, force of attraction is what? High, right? So you just have to remember this thing, less space, more force of attraction. Okay, so when we observe more space, more interstitial space among these particles, force of attraction is less. Do you all agree with this? Haven't we studied about it? Great. So in case of solids, there are there are no spaces actually. They are very compact. And why they are compact? Because these particles are experiencing force of attraction which is at rate highest among these three states. If you are very clear with this idea, definitely you would have cracked this question. So let's take example, we are having water which is liquid, air which is water, gas, wind, again it's in the gaseous state. We are having air which is in gaseous state, sugar which is solid, oil which is what, liquid, oxygen it's your gaseous, water is your liquid, sugar is your what, solid, salt that is solid, juice is liquid, air is what, gaseous substance. So we need to understand the increasing in the increasing order of force of attraction. So what should be the order? Increasing from gas to liquid to solid. If this should be the trend, tell me based on this which option is the right. I have given like so many hints here. Gaseous, then liquid, then solid. Option C obviously. Okay. So force of attraction among these molecules or particles is getting increased. Oxygen is in gaseous state, so force of attraction is negligible. Moving ahead, water which is in liquid state, force of attraction is at moderate level, and in sugar it's very highest among these all. Got it? Moving ahead. On converting 25 degrees Celsius, 38 degrees Celsius and 66 degrees Celsius to Kelvin scale, the correct sequence of temperature will be. So these are your options. Option A, 298 Kelvin, 311 Kelvin and 339 Kelvin. B is 298 Kelvin, 300 Kelvin and 338 Kelvin. Option C, 273 Kelvin, 278 Kelvin and 543 Kelvin. Option D, 298 Kelvin, 310 Kelvin and 338 Kelvin. I hope you know the formula what we are supposed to do here if we want to have that interconversion from degree Celsius to Kelvin. It's very simple, I'll tell you. What you are going to do, 273 plus temperature which is there in degree Celsius. That's it, your answer is done. Have you all got it? Okay. So we are provided with the first temperature 25 degrees Celsius. 273 plus 25 has to be what? 298, right? 298 Kelvin. Next we are provided with 38 degrees Celsius. Then 273 plus what? 38 is there. Is going to give you 311 Kelvin. Okay. And we are provided with 66. 273 plus 66. Right? Okay. Then we are having 339 Kelvin. So what are your answers? 311K, 339 and 298 Kelvin. Find out the option for it. It's right there. Option number A. Option number 1. Okay. So that was all about today's session, students. So in today's class we have covered about interconversion of matter and followed by effect of temperature and pressure. I hope you enjoyed this session, and soon we will be there with a new session. Okay, till then, bye bye, take care.